Hello, good day. I hope you are all doing well once again. I'm happy to come your way with another video, which is more of it's a tutorial video. And the aim is to assist you to run data sets which you can use in your research analysis. So for the past, almost about 2 weeks, I've taken you through how to go about exploratory factor analysis. But before you go into exploratory factor analysis, I introduce you to how to prepare your data, how to test the reliability of the data, how to look at the normality of the data. And then after testing the normality of the data, you choose a statistical method which will go with your data set. If your data set is normally distributed, there are statistical tools that we use after you have determined that your data set is normally distributed. And if your data set is not normally distributed, there are also statistical tools that you have to use. Yeah, so I've taken you through all the methods, processes, and approaches. So if you want to go over this, look at my videos, my previous videos, and watch them, and you understand them more. Okay, so all the things that we did, they were related to what I have termed as stage 1. So here, or today, what I'm going to do is I want to take you through what I have termed as stage 2. And in stage 2, this is where we build what we call fuzzy synthetic evaluation. Other studies, other papers, other literature we say fuzzy synthetic evaluation modeling. Others say fuzzy synthetic modeling. Others say fuzzy synthetic logic. Others say there are so many names. Others just put them fuzzy synthetic. Okay, so depending on the paper that you are using, you have to, you can use any of them, and any of them is okay. So that's what is with this stage 2, and this stage 2 will bring us to the end of doing exploratory factor analysis or factor analysis, and then moving on to do fuzzy synthetic evaluation. So in future, what I would do is that I will take you through what we call structural equation modeling. By then, because after this, I'm expecting that we'll be able to write about 2 or 3 papers from what we have done so far. And then once we are done and we have submitted them, I will introduce you to what we call structural equation modeling. And then I'll also take you through what we call analytical hierarchy process, AHP. Yeah, and then also artificial neural networks. So there are so many things ahead of us. So I will encourage you to really consume these videos. In addition, I will also encourage you to look at what other professors, other scholars are also doing. There are some scholars too who have also put together videos which are explaining some of these things I'm showing to you. So you can also take the opportunity to watch them. So in addition to what teaching you, I'm giving to you, you can also decide to read more. You can read more on this. You can read more on this by just Googling. Yeah, there are a number of studies, there are a number of research outputs which are on fuzzy synthetic evaluation. So read, watch, and then also apply. The last aspect is application. Because if you don't, so far, I think what I'm not really saying, yeah, we are doing well and we are putting papers together and all that, but I think I don't normally get feedback. I don't know whether you guys are watching the videos or you are not watching. Yeah, because, and maybe then it's a good news. Maybe if you watch the videos, everything that you see in the videos are okay. All the things that you see in the videos are okay. If that's the case, then that's good news. But in case you have questions, please don't hesitate to get in touch with me. I'll be so glad, I'll be so happy if you are able to get in touch with me so that we all know what we are doing and where we are going. Because it's not nice feeling when students or the people that you are mentoring, they have questions, but they are finding it difficult to ask the questions. So please watch the videos, and if you have questions, you can get back to me. And also do your best to apply what I'm teaching you. So if you don't have a soft any of these softwares, get them. And then where you need assistance in terms of maybe getting any of these softwares, you can reach out to me. And also where you have the software and you are finding it difficult to either install or use them, get in touch. I want you to apply. The application is very important because if you watch the videos and you are so happy about the videos and everything in the videos, all the things in the videos are okay, and you don't apply them, you won't get much. Yes, at the end of the day, we'll write papers and all that, but what is going to happen is that I'll do more of the running of the data. So you may be missing out the aspect of you getting in touch with the the running, like you running it yourself, getting to know whether the results are good or bad or something. So please, it's just an advice. Okay, let's move on. So we are dealing with fuzzy synthetic evaluation, but before we move on, as I always do, I want to issue a disclaimer that the materials used in this tutorial video are for only educational purposes, with no intention of making profit or gaining a financial advantage. The materials have been cited or used fairly for illustration and explanation to students only. So I don't have any intention of making money out of this, or maybe I don't have intention of using it uh, that will have negative impacts on the original owners of the document. And they have all been used and cited fairly for the sake of illustration. Okay, so we'll go into fuzzy. So fuzzy has been around for some time, and we need to know the genesis. Well, how did they come about? Who brought about this whole idea of fuzzy? So I've been able to put together something simple, something little. Fuzzy actually was, I would use the word invented, or in theoretical point of view, we use the word more propounded by Lofty Alaska Zadi. So Lofty Ziaka Alaska Ziadi, Lofty, he is a person, this is the man who came about with this fuzzy idea. Okay, so this is the man. And he died at I think he got about 96 or 97 years. Yeah, so he came about with this idea of fuzzy. So let's go through this. Something that Chiradib Basumolik, a technical writer, decided to put together concerning fuzzy. So fuzzy logic, or fuzzy, this fuzzy synthetic that we are dealing with, is an aspect of what Lofty-Zade came about. And Lofty-Zade came about or invented what we call the fuzzy logic, which formed the basis of all the fuzzy terms, fuzzy theories, all the fuzzy things that you can read about. Yeah, we'll see them very soon. So what is this whole fuzzy logic thing? So fuzzy logic is defined as a problem-solving approach that proposes multiple true variables, which can be in any real number between 1 and 0, as opposed to the binary version of the truth, which is so. I mean, another circumstance, what we know is that normally, if you want to know, for example, are you good or bad? Or so if somebody asks you, have you eaten? Normally, the answer is supposed to be yes or no. binary, two responses. Yes, I've eaten. No, I've not eaten. But there are situations where you yourself, you don't know whether you have eaten or you have not eaten. Or there are genuine reasons and situations where you are stuck in between the yes you have eaten and no you have not eaten. So in that case, the question is, if you are going about framing your responses and trying to determine the truth, how do you determine that? Because normally you see that somebody asks the question that I asked, and somebody will say, oh, somehow I've eaten somehow. I'm not sure. I feel like I have some food in my stomach. Also, I feel like, oh, I feel like I'm full, I'm not full, and all that. Yeah. Okay. So in a nutshell, to just simplify it, fuzzy logic goes against this binary truth, where we always say is yes or no, is blue or black, is white or black, is either you are for us or against us, or either you are eating with us or you are not eating with us. Fuzzy logic is so like fuzzy logic is like the way we think, the way we go about our things. So yeah, so it's either you are this or that. That's what we know, and that is what has been established over the years. But when Lofty Zadi came in, he said that no, I think that we need to capture a situation where somebody is not so sure about the answer that the person is giving. Okay, so that brought this whole idea of fuzzy synthetic. Get more. So in our everyday lives, we cannot always choose to simply say yes or no. Yes. So as I said, you cannot. It's not all situations which are yes or no. This happens because you may encounter circumstances where you lack sufficient knowledge to make a judgment. And that's true. Alternatively, you could be slightly puzzled yourself. For instance, if someone asks you if you are present on a specific day next month, you likely not respond immediately with a yes or no, because you cannot be certain about your plans that day. And that's true. Yeah. Not easy, right? Yeah, it's true. It's not easy. In such a scenario, fuzzy logic, a form of artificial intelligence, enables computers to handle ambiguous input data. In other words, fuzzy logic, as I mentioned, is a big thing. It's a great theory, and it's a great thing that this guy came out with, and it is seen as the precursor of artificial intelligence. Artificial intelligence, booming of AI, the computer age, and all that. Yeah, and actually, he came out with this idea, I think, in 1965 or so. Yeah, around 1965, before we first got the IBM and Microsoft's computers and all that. He came out with this. So let's keep on going. Fuzzy logic is used as a decision-making strategy when a machine learning frames. Okay, it may be stated generally as evaluating natural values 0 and 1. Fuzzy logic is applied to represent real numbers between 0 and 1. In other words, if you are looking at fuzzy logic, it's not 0, it's no, or yes. Actually, the answer is within a continuum or a continuum. Or in other words, what we call a spectrum. It's within a spectrum. So even in politics and even the way in our social life, that's how we see things. Like you meet somebody and you ask the person, like currently what is going on in Ghana with the NPP and NDC. And somebody who is an NDC person or an MPP person, you ask the person in the next general election, are you sure you are going to vote for candidate A? A person will say that I'm not so sure. Maybe I may. I'm not 100% sure. Let's see. Yeah. So in that case, this person cannot be captured or cannot be put in a box. And in a box here, I'm referring to just saying yes or no. The person is not so sure. And even sometimes this person who is thinking about these politicians, the person is even thinking about other alternatives. Maybe traditionally the person is an NDC person, or traditionally the person is an NPP person. If you go to America, traditionally maybe the person is a Republican or a Democrat. When it comes to Australia, maybe the person is a Liberal or a Labour. When it goes to Australia, I mean UK, the person may be a Conservative or Labour. But looking at what is going on in their respective countries, the person may be thinking about other things. And even when it comes to even about belief, you see that somebody may be in a certain party, somebody who calls himself or herself a social democrat. And these social democrats, you see that a person at the same time believes in capitalism and so forth and so forth. So what this whole thing is saying, which is realistically is true, is that the world that we live in is not always a binary situation where everything is either A or B, black or white, 1 or 0, A or Z. That's not the case. That is what this is trying to say. So fuzzy refers to anything that is rather ambiguous. When a scenario is ambiguous, the computer may, so normally this fuzzy is prominent in the computer world, in the IT world. According to the Boolean logic, 1 represents true and 0 represents false. In contrast, a fuzzy logic method considers all the ambiguities of an issue, where there could be more potential values than the true or false. Yeah, as I said. Fuzzy logic is used to achieve precise values as problem resolution. So because things are ambiguous and people don't have yes or no answers, there must be a way where we can find out the exact answers of how people think, how people feel, and how people respond to situations. Okay, yeah. So when later on we'll see that when we start doing this, we see that people don't respond to things like 1 or 2. You see that people will respond to things around maybe 1 point something or 0.43 something. Okay, which defeats the binary concept of 1 or 0. Okay, so fuzzy logic was created in the 1965 at the University of California by Lofty Zadie, who dubbed it fuzzy. He believed that conventional computer logic, and it's, as I said, now it's in the computer world, but now it's not only used in computer. In fact, fuzzy is even prominent in the machines that we use to wash our things. I mean, this dishwasher, and then the ones that we use to wash clothes and all that, and so many other things that use IT, which things are complicated. Yeah. Okay, so he believed that conventional computer logic could not handle confusing or imprecise data. Like humans, a computer may integrate a wide range of values between true and false. These can be definitely yes, maybe yes, I can't say, maybe no, and definitely no. So one of the things that is so easy for you to understand, which has something to do with the fuzzy logic, has to do with this Likert scale. Yeah, because normally if you look at Likert scale, we are looking, and I mean, you take one variable You want to know whether the financial conditions in Ghana are good or bad, or currently people are not doing well or not. And as a concern, the answer should be yes or no, right? But with Likert scale, for example, you are given opportunity to respond in a spectrum. So you respond that, oh, maybe Ghana is hard. Some will see it to be maybe, some will say, I can't tell, some will say maybe no, some will say definitely no, some will say yes, so forth and so forth. Okay, so there are a number of types of fuzzy. Okay, there are a number of them. So I think you can read more about this. And then even the difference between fuzzy logic and probability. What's the difference? Yeah, for the sake of time, I don't want to spend too much time here so that we don't. So in a nutshell, fuzzy logic helps you to get a precise, objective figure for an imprecise situation, for an imprecise, ambiguous, indefinite situation. Okay, let's keep going. So what do we do next? So the next thing to do is to bring it back to what we are doing. I don't want to bombard you with so many things. You can read them. Yeah. But to conclude, there's also a book which has been written. You can get access to this book. I think it's free. And it will give you an idea, a historical background of how fuzzy came about. So in 1965, Lofty's idea, professor of electrical engineering at the University of California, Berkeley, published the first of his papers on the new fuzzy set theory. Since the 1980s, this mathematical theory of unsharp amount has been applied in many different fields of great success. The word fuzzy has also become a very well-known among even non-scientists, thanks to advertising campaigns for fuzzy controlled household appliances, as I said. Washing machine, I think that's what I was trying to say here. Washing machine, yes. Normally, if you have bought a washing machine before and you read the content, they talk about this fuzzy thing in there. Fuzzy controlled household appliances into their prominent presence in the media, first in Japan and then in other countries. On the other hand, the story of how fuzzy set theory and its earliest application originated remains largely unknown. Yeah, but I mean, the one who propounded it, made it more profound in academia is Lofty. In his book, The History of Fuzzy Set Theory and the Ways It Was First Used are incorporated into the history of 20th century science and technology. Actually, I mean, this is it's a great invention, honestly. And if you take Lofty documents and papers and scholarly works that he did, you can see that his works, some of them have been cited over 10,000 times and all that. People really look at this. Today, fuzzy set theory is the core discipline of soft computing and provides new impetus for research in the field of artificial intelligence. Yes. So anybody who wants to go into artificial intelligence, one of the things that you will encounter with your studies is the fuzzy synthetic modeling or fuzzy synthetic logic. You can encounter that. Okay, so these are some of the things. I just want to introduce you to some of these things so that you get the understanding. Then here too, there is some kind of explanation or some form of explanation to be given. Fuzzy logic is an approach to variable processing that allows for multiple possible true values to be processed throughout the same variable. Fuzzy logic attempts to solve problems with an open, imprecise spectrum of data and heuristics or heuristics that makes it possible to obtain an array of accurate conclusions. Fuzzy logic is designed to solve problems by considering all available information and making the best possible decision given the input. And it stems from the mathematical study of multi-valued logic. Whereas ordinary logic deals with statements of absolute truth, as we all know. Is it green or blue or what? Is this object green? Yes or no? Fuzzy logic addresses sets with subjective or relative definitions such as tall, large, or beautiful. These attempts to mimic the way humans analyze problems and make decisions in a way that relies on vague or imprecise values rather than absolute truth or falsehood. In practice, these constructs all allow for partial values of the true condition. Instead of requiring all statements to be absolutely true or absolutely false, as classical logic, the truth values in fuzzy logic can be any value between 0 and 1. This creates an opportunity for algorithms to make decisions based on ranges of data as opposed to one discrete data point. Today, fuzzy logic is used in a broad range of applications, including aerospace, engineering, automotive, traffic control, business decision-making, industrial processes, artificial intelligence, and machine learning. And then it goes on to give some brief history of how fuzzy logic came about, and then other definitions, and even other types. I mean, the types, examples of, yeah. So fuzzy synthetic logic is just an aspect of the fuzzy logic theory. It's just an aspect because you have other aspects as well. Okay, fuzzy logic has its own pros and cons, so you can read about that. So the advantages and disadvantages of fuzzy logic. The use of fuzzy logic in data mining, the use of fuzzy logic in machine learning, the use of fuzzy logic in artificial neural networks or neural networks, and then and so forth and so forth. But to bring this whole thing to an end before we go into our analysis, there are 4 main components which I have seen since I've been using fuzzy for some time now, which normally studies and scholars talk about. These 4 components include the fuzzification, the fuzzy rules, setting the fuzzy rules or the knowledge base, and then the inference method, which you call the fuzzy inference, logic inference or fuzzy inferences, and then the defuzzification. Okay, so you can read more about these things. Okay, so I'm taking you back to what I always do, which in this video, that's going to be our main focus. And the focus is going to be that we are going to take one paper, which will be a guide. And based on the paper, we will use it to run data sets. And these data sets, they will help you to understand how these papers came about. Okay, so today I'm using Dr. Wuni's paper. So the paper I recommended to you was this paper from Dr. Wuni, which is Quantitative Evaluation and Ranking of the Critical Success Factors of Modular Integrated Construction Project. When I checked this paper and then a similar paper that Dr. Wuni also wrote, it seems the method that was used or the approach that was used is similar. Yeah, so I decided to use this one, which is also almost the same paper, modeling the critical risk factors for modular integrated construction projects. But the reason why I decided to switch to this paper is almost the same as this, is that within this paper, he has a portion where he talked about the fuzzy synthetic logic. Okay, like he did a piece of review, so I thought it was good. Yeah, the other one he didn't do the same, or he didn't do it. So it's just something that will help you to just when you are reading, so you can read that paper, you can read this paper. They are, I would say almost everything in the 2 papers are I would say they are the same, and it's almost the same thing that we have been going through with respect to how he came about the factor analysis and other statistical tests that he conducted. So let's go through what he wrote here. So this is what he wrote about the fuzzy logic and the fuzzy synthetic evaluation analysis. The fuzzy logic, based on fuzzy set theory, was propounded by Zadeh. as I have shown to you, Lofty or Lofty-Zadi in the 1965. And we know it to be a mathematical theory. Others can also say it's kind of computer or IT-based theory. Any of them that you want to put it, it's fine. That deal with objects which are imprecisely defined with degrees of a continuum, a spectrum. So Zadi in 1975, another paper that seems that they wrote, introduced or added to it that introduced logistic variables to approximate reasoning using a fuzzy set. Fuzzy set theory has the power to precisely and objectively explain and quantify ill-defined and imprecise information. Mathematically, a fuzzy set takes the form of membership functions, which allocate grades of membership to define the extent of association of each element in the universe of discourse to the concepts represented by a fuzzy set. And he cited another paper that I will use. So in this series, what I'm going to do is that I'm taking you through three different papers. Yeah, so that you get a holistic understanding of the fuzzy. So after today, I have 2 more videos only on fuzzy for you. What I'm going to do is that in the subsequent videos, I will not use Dr. Wuni's paper. I will take another paper. The second video, I will take Dr. Robert's paper. And then in the third paper, I'll take Akomea-Frimpong paper. So by the time I go through these 3 papers with you, I'm hopeful that you grab a lot, which will help you to do your fuzzy synthetic evaluation. Okay, so these membership grades, so it's assigned membership grades are represented using a real number that range between a closed interval of 0 to 1, where 0 represents no membership and 1 represents full membership in the fuzzy set. It employs linguistic variables in terms to model the characteristic vagueness in the human cognitive process. For this reason, fuzzy logic has been used in multiple attribute decision-making problem. In other words, has been used in so many fields, not only in engineering. Notably, the fuzzy synthetic evaluation analysis is widely used. Yeah. So, and I think one of the reasons why we use this is to quantitatively evaluate a model risk factor, not only risk factors, but quantitatively, we want to determine the value of something. Because here in engineering, especially in engineering management, there are so many things that people have views and opinions and all that on. Normally, people don't express these binary views on things. They don't just say yes to this or no to that, but rather they tend to have a range of views. So for us to get an objective one single value, which will represent the opinions or the views of people, is good. We go for the fuzzy synthetic evaluation. So I'm not surprised that a number of studies within the construction and engineering management CEM research domain have used this method. And even with risk, it's more profound. But it's not only used for risk analysis. It can be used for other things as well. So for instance, Akomea-Frimpong used fuzzy synthetic evaluation, FSE, to evaluate and rank risk factors in public-private partnership water projects. Wuni and Shen use FSE to allocate risk events in the supply chain of MIC. And Zafa use FSE to analyze time overrun risk factors in highway projects. This study used FSE to evaluate and rank the risk factors in the implementation of MIC project because the technique can be used to make meaningful quantitative assessments of the fuzzy linguistic variables, such as, least critical failure. In other words, like you set a linguistic variable or language for that, and you do that based on how people express their opinions, and then you assign values to them. Okay, this research adopted the FSE protocol established in Akomea-Frimpong. So always when you are conducting a fuzzy synthetic evaluation, it is advisable that you pick a study or an approach, because when we are done with the 3 papers and you yourself decide to read other papers, you see that there are some differences. The differences are not much, but you see some differences there. So whatever approach that you think, what method, whatever process that you think is okay for you, when you are using it, make sure you cite the person that you are following to do your work. So they use Akomea-Frimpong. And this is how Akomea-Frimpong sets their work. To them, first you need to determine a basic set of risk factors. So if you are dealing with risk factors, in other words, determine your variables, determine your factors. Just as we did it with the literature review and the factor analysis. So that's the first step. Then the second thing is establish a set of grid of alternatives. In other words, help us to know the linguistic values of the things. So we know the factors. So what are the linguistic variables or values of that? And normally, as I said, if you are using a Likert scale, the Likert scale will help you out. But it's not always the case that it should be a Likert scale. You can come up with your own set of grade alternatives, where you can say that 1 is strongly disagree, 2 is disagree, 3 is neutral, 4 is agree, and then 5 is strongly agree. Then from there, you have to compute what we call the weightings for each of the variables that you identified. Okay, and then if you have something like with the exploratory factor analysis, if you have your principal component, you have to do that. And if you are using CFA, is confirmatory factor analysis too, normally you can also do the same, because with CFA already you have established the factor groupings from theory. Then from there you compute the fuzzy synthetic evaluation matrix for each risk factor, and then in addition you also, if the group there, you can also do that, which I also teach you. It's not that difficult. Then from there you compute a final fuzzy evaluation matrix where you combine everything, including the principal components or the principal groups. We'll do that one too. Then normalizing the final fuzzy evaluation matrix to obtain the factor groupings and the criticality indexes. So the final thing that we'll do is we'll compute what we call the criticality indexes. So we'll go there. Yeah, so it's not a big deal. So let's start going. Already I have put together something which is almost the same thing as what we just did. So first, determine a family of variables. In other words, determine your variables. So where do you determine your variables from? We have done this thing over and over again. I've took you through. I took you through this. I've taken you through this over and over and over again, where I told you that if you want to get your variables, you have to conduct a thorough literature review. So we have done this, and I'm hopeful that you know what this is about. Okay, so that is the first thing to do. Then establish the set of grade alternatives. So this is where you set your linguistic terms. Then the next thing to do is you need to compute the weighting functions, which we are going to do. But there are so many ways by which you can compute your weighting functions. We have especially with respect to Likert scale, you can use the AHP, you can use the direct point allocation, you can use the unit weighting, you can use the tabulated judgment method, you can use the normalized mean method. And then once you are done, you need to come to the stage or the step where you have to compute the membership functions of each variables in the group. So we'll get there too. Then from there, you have to determine the criticality indexes of the groups and then the overall criticality index, which you use to determine whether your factors are critical or they are not. Yeah. So first you determine the criticality at the individual level. Then you also look at it from the overall point of view. So we'll do that as well. And then you can go ahead to design a linear model for the analysis. And this one is your own choice, because some studies or most studies I've seen, they don't do that. So you can decide to do that. And then you interpret your results. Okay, so now let's go into the paper that we are using. So I'll be going through that, but whilst I'm going through it, I'll also be running some things. Some of them I've done them already for the sake of time, so that we don't spend too much time here. So I'll just take you through them. Yeah. I'll just take you through them so that we don't waste too much time. And some of them too, I will explain them to you so that you get them. Okay, so while some will run and others, we just look at what I've run. Others, what we'll do is that I'll make sure that we all do it together. We'll do something together for you to understand it. Okay, so let's get into this. So the paper that we are using is this paper. Sorry. Yeah, that's this paper. So get this paper and also get this paper as well. And the title of this paper is Modeling the Critical Risk Factors for Modular Integrated Construction Project. It's almost, the approach is the same. I would even say the same. So I would not even say almost, it's the same as this. Okay, so let's start. So what do you do with the methodology? First, you need to do prior literature review. And once you get your factors, you put them in a survey. And then when you get a survey, you can either decide to do a pilot study, so that, especially if you are doing this with respect to a particular jurisdiction or country, it's better you give it to the experts in that area, so that they will confirm that the survey that you are going to use are okay or not. And where they have comments and they expect you to make changes, accept. I mean, if they are necessary, accept them and make the changes before you finally distribute the survey. So when you distribute the survey and you get your responses from the participants, or you can also choose to call them respondents, as we have done, what you have to do is that, like what I did with you in the other videos, you need to do some kind of data cleaning. After doing data cleaning and getting the final data set, the first thing that you have to do is that you need to conduct your reliability test. Yeah, so you conduct a reliability test as, okay, so I mean, we all know we are using SPSS, okay? So SPSS, so you conduct a reliability test using a Kumbat alpha. And I explained to you that a Kumbat alpha of 0.7 and above is acceptable. Yeah. So you get that. So what do you do next? The next thing that you have to do is you need to determine the normality of the data set, because once you determine the normality of the data set, it will guide you to choose the statistical tool that you use to analyze the data, especially where you want to compare. I mean, you are undertaking a study where there are groups. We have samples. We have groups. I mean, samples for groups. It's important that after you have determined the normality of the data set, you need to choose the right data analysis tool. So this was done, and it was established that the data set was not normal using the Wilk-Shapiro test. It was not normally distributed. Not normally distributed. So if you want to compare the groups, which in this case, he decided to compare the responses from the industry and academia. That's what he did. Okay, so because he was just comparing two, I also explained this to you in the other video. If you are comparing two groups and the data set is not normally distributed, then it's good to go for what we call the man-Whitney U test. If you are comparing more than two, then it's good you have to go for the Kruskal-Wallis test. Okay, so this has been done, and the explanation been given. Then after that, you went ahead to conduct the exploratory factor analysis. So with respect to the exploratory factor analysis, he determined the KMO, the Bartlett sphericity test, or the Bartlett test of sphericity. And then also, he also determined the correlation and all that. And then once again, he determined the Cronbach alpha. Everything he did, he made sure that all the conditions relating to factor analysis, all the conditions were met. So he did that, and finally, he got his factor analysis results. And the factor analysis result, he has shown them down here. So I want to show them to you. Okay, so this is the initial analysis with respect to trying to look at the mean, the standard deviation, ranking them, the normality test, which Shapiro-Wilk test, and then also the comparative test or the comparative analysis with a man-Whitney test, looking at the comparative samples, data samples from academia and from the industry. So this was also done. And then he did a factor analysis. And with respect to the factor analysis, I want to show you the results. These are the results that he got, the factor analysis. So he decided to put it this way. But if you look at other studies, people have a way of also showing their factor analysis. Any of them is acceptable. Okay, so here you can see the factor loadings, the eigenvalue, the percentage of variance explained, and the cumulative percentage of variance explained. So all presented, and he was able to extract 4 main components. So in other words, 4 groups, 4 principal groups. Okay, good. Then once the factor analysis was done, the next thing to do was to start with the fuzzy synthetic evaluation. So this is where our main work starts. So drawing on the outcome of the factor analysis, 3 levels of fuzzy synthetic evaluation. So this fuzzy synthetic evaluation that we are looking at is a multi-level fuzzy synthetic evaluation model of risk of MIC projects are derived. The 3rd level involves evaluation of the 3 levels. So what are the 3 levels? The 3 levels include the first one being the evaluation of the criticality of the risk factors. In other words, the individual factors. You can use the fuzzy synthetic evaluation to determine their criticality within each of the groups from the factor analysis. And the 2nd level involves assessment of the criticality of the groups. So first, you determine the criticality of the sub variables or the variables or the factors within each group. Then when you come to analyze or assess the criticality of the groups, we say you have reached the 2nd level. Then the overall level, when you determine the overall outcome or the overall criticality of all the factors, including the groups, then we say you have reached the 1st level. So that's how it works. So with respect to this fuzzy synthetic evaluation that we are doing, it's more of like a 3-level, or what we also call it a multi-level fuzzy synthetic evaluation modeling. Okay, that's good. Now let's keep going. And let's also call it the multi-factor analysis. Okay, so this is considered as a multi-factor and multi-level of the risk. The systematic implementation of the multi-level is shown below. Okay, so he's just trying to tell you that if you want to understand this multi-level thing, how it was done, I've explained it to you, and I've also shown my own some things that I decided to put together. So the same. Okay. Okay, you have a question. Let's get back to me. Okay, let's keep going. So let's start from let's get back to this. So first, determine a basic set of risk factors or factors. So we have done this. We have our factors. So I'm going to use what we did yesterday, where I came about with some data set. Okay. So I must say that there are two ways by which you can put in this data. Yesterday, I just showed you where you are entering the data straight from your survey. But you can also decide to put it in an Excel form. You can decide to put your data set in an Excel form like this. First, you can decide to put it in an Excel form. And then once you put it in an Excel form, you can decide to import it into your SPSS. That's also another way by which you can get the data set into your SPSS. So here you click Excel and then you choose. Okay. But here, I've already entered it, so I don't need it. But if it was to be the case that I was going to use the Excel data set, then this is how you have to do it. Or this is how I should have done it. You have to come to File, you click on Import Data, and then you click on Excel. Then you open the box, then you just pick the data set. But I've already entered them. I entered them manually, or I entered it by myself, or I entered them straight away into the SPSS. So there's no need for us to do it again. Okay. The another thing too yesterday, I think maybe I didn't also explain it much to you, has to do with you can also decide to bring in the values. It's not important, actually it's not needed. Okay. I'm talking about trying to set the linguistic terms of variables. You can decide to trying to show the linguistic value, where you can see that one, and that's what was in our like skill, where we said 1 is strongly disagree, 2 is disagree, 3 is neutral, 4 agree, and then 5 strongly agree. Okay, you can decide to bring this, but if it's not there, if it's not there, there's nothing wrong. No one will penalize you, or you won't receive any query from anyone. And still, if you run your data sets will run. Okay. Then also with respect to the measure, some people, I've also seen studies where people, instead of, because this is something that we ranked, or we have ranked them already, but you can also see that some studies and even some videos see that they make this as the measure as scale. Any of them is also acceptable. Scale, ordinal, acceptable. Okay. This will also not affect your results. Okay. Now we have this. So what do? We have to run our factor analysis. I will not go through all the other ones because we did this yesterday. And even with the factor analysis to yesterday, we did it, but I just want to do it again. So you click on this, you select all these things, you click continue, extraction, you pick principal component analysis, script plot, unrotated factor, everything you clicked. Make sure your eigenvalues are greater than 1, continue. Rotation, you can take Varimax, but you need to know why you are taking Varimax. And yesterday I took my time to explain this to you. And then the scores, you can decide to just suppress the outcome by saying that if a factor loading is not 0.4 and above, it should not be included in this analysis. Or any of them that you set, it could be 5, 0.5 could be 0.6, could be 0.7, but you have to choose these things with a reason. There must be a justification for that. You click OK, and we get a results. So the results are showing that our KMO is okay, Bartlett's test of sphericity is okay, and then the eigenvalue. So we are seeing that the factor analysis, the principal components or the eigenvalues, we are seeing a two-factor extraction or two group have been extracted by the PCA. So 2. And then the script plot confirms that 2. Okay. Then when you come down, you see the rotated and then unrotated. So always use the rotated component very much. So you can see that CSV, CSF1, CSF2, they all belong to component what? They belong to component 1. They are clear. Component 2, and then 7, 8, 9, 10, 11, they belong to 1. CSF3, 4. CSF3 belongs to 2. CSF4, definitely it will belong to 1 because 0.588 is bigger than 0.537. CSS5, yeah, yes, this will belong to this, and this will belong to that. Okay, so if you get a situation where the two values can be seen in the same, you choose the one which is higher. So in terms of the factor loadings, choose the one which is higher. Okay, so everything is fine here. So what do we do next? So the next thing to do is for me to put them in the form that Dr. Wuni put his work in the factor analysis. So we're also going to put this in this form. The eigenvalues, the factor loadings, the percentage of variance and all that. So let's see. So I've already done that. Once again, as I mentioned, for the sake of time, because if we were to do this one by one, it take us the whole day. So I've done this already. So as you can see, the coding, the factor loadings, eigenvalues, I decided to give them names. Okay. And these represent some factors. It just something. I have made this thing up. I have made these things up, and I have termed them to be, or I'm saying that they are factors that represent things that hinder the acceptance of sustainability practices in the construction industry. That's my point. Yeah, but I mean, it may not be true, but it's just these things are made up just for tutorial sake. Okay, so we have this factor loadings, eigenvalues. The eigenvalues exact the same thing. I've extracted them from here. So the same thing. Yeah. Yeah. Okay. So I have all that done. Everything done. So we have this table. So what next? Let's keep going. So we can be able to maybe beat some time or something. The next thing to do, once you have your factor analysis done, is for us to compute what we call the weighting function of each of the factors and then the groups. Remember, in this factor analysis, we got 2 groups. As you can see, 2 groups, which I have termed them sociocultural factors and financial factors. Yeah, based on the very mass rotation, we got 2 groups. Yeah, so 2 groups, 2 components. here. Once again, I want to show them two components. And then the factors that come under them. So we want to get what we call the weighting functions or the weightings. So how do we get them? Okay, so to get the weighting functions, what we need, one, is that we need the mean score. Good. So this is where the question will come, that question will come in, or this is where you have to determine it. So there are so many ways by which you can go about getting your weighting functions. So you can do this by using AHP. You can use that's analytical hierarchy process. You can use direct point allocation. You can also use unit weighting. You can use tabulated judgment method, and you can also use the normalized mean method. In our case, we are using the normalized mean method. In other words, we are using the mean method. I mean, the mean scores. Okay. So that's what we are using for ours. But if you read another paper and the paper has used AHP scores, or the outcome of an AHP, or an outcome of a tabulated judgment method, or an outcome of a unit weighting, or an outcome of any of the methods I've mentioned, don't be surprised. Okay, so following the works of Zhu et al. 2010, the weighting functions in this paper were derived through the normalization of the mean score, another with the mean score. So as you can see, I just put it here, the mean. Where did we get a mean from? The mean are just from if you run the basic descriptive statistics, the mean, which I told you in the other video that they are called, they can also be called the mean scores. I mean this one. Okay, so and that's exactly what Dr. Wuni also put in his paper. So let's look at it together. So yeah, as you can see, is that okay? Yeah. So these I mean these means. Okay, so so what do you do next? So the next thing that we have to do is that we need to put all the means in a group together. By putting them together, that means you are going to add. So for example, 3.8 plus 3.39 plus 3.38 plus 3. Up to all the mean or the mean score within, example, group 1, put them together. And the total, you write it somewhere here. So the total of all the means here, you add, you get 29.59. The total of all the mean in group 2, when you add them, you get 29.38. The total of mean in group 3, when you add them together, you get 9.86. The total of mean in group 4, when you add them together, you get 6.59. Okay, and that's exactly what I have also done. So when you add all the mean here together, you get 88.882. When you add all the mean in the second group together, you get 12.1. Yeah, so add some, as you can see, add them. Okay, then what do you do next? So the next thing to do is to allocate the weight. I mean, allocate their contribution, the contribution of the mean that is coming from each of the variables or the factors to the whole group. Because the 38.81182 represents the total mean of the group, the whole group. So with this 38.882, what is the percentage of, for example, if you take political extremism or old age and disability challenges or acceptance, I would say non-acceptance rather, acceptance or unacceptance of new technology. Okay, so what's the contribution? So to get the contribution, this is what you have to do. When you pick this mean score of, or if you pick a mean score of any of the variables, you divide that mean score by the total mean of the group. So that means 4.2273 divided by the total mean of the group total mean of the group, which is 38.882, and that will give you this. You do the same for each of the variables or the factors in the group. And the good news is that, or normally what's supposed to happen is that when you add them together, you're supposed to get one. If you don't get one, or you go more than, if you get more than one, then there's something wrong that you have to check. Okay, so you do the same thing as I did it for group 1, also in group 2. So group 2, you add all the mean together to give you 12.2122. And then with each variable, you just take this and divide by the total. And get a total. Okay, so now we have this. Now let's determine the weight per group. So now we have moved from the variable or the factor level. Then we are going to the group. We are looking at this from the group perspective. So if you take group 1, what is the weight? For us to get the weight of the groups, what we have to do is that we have to do a further addition by adding the total mean of the groups together. So 38.818 plus 12 point something. When you add the two together, it give you 51.030. Okay. And then when you add the two together, for us to determine the weight of the group, for sociocultural factors or sociocultural factor group, what we have to do is that we have to pick the 38.8182 divided by the total of this, and that will give us 0.761. And when we take this one we divide, it should give us this. So the two of them should also give us 1. If you also don't get 1, then there's something wrong also somewhere that you have to check. So now we know our weighting. So we have been able to determine what we call the weighting function, or we have been able to determine the weight. Simple. Don't want to be quadrant with too many difficult jargons, which are difficult to understand. So we have completed this table, which is in the process that Dr. Wuni said. That's the third item. So we have completed the first. We did the first one. With respect to the setting of the grade of alternatives, we know that one already from the Likert scale, even from the SPSS that shows you strongly agree, disagree, neutral, and all that. And then with this, we have done this. So now the next thing to do is compute the fuzzy synthetic evaluation matrix for each of the risk factors. So that's what we are going to do each. So let's go there. So how do we do that? So let's see what Dr. Wuni did, and I'll also show you exactly the same thing in what I've done in my Excel sheet. Okay, so we have already tackled this. So this one is just giving you, if you want to compute it like manually, or yeah, something like that. So, when I say manual, I mean without any, you don't have any Excel software. You don't have MS Excel spreadsheet software, and you want to just take a sheet of paper and just compute it yourself with a calculator. That's what he has done here to show it to you. Yeah, but it's the same. If you use Excel, you get the same answer as I did. Okay, so now we have this. We have this table. So what is the next thing to do? So the next thing to do is compute what we call the membership function of each of the factors and then the group. So here, if you see the CRF, he's talking about the critical risk factors. In other words, each of the variables or each of the factors. And then here, he termed his groups as PRF, but it depends on you. You can term your group whatever. It's not a big deal. Okay, so how do we determine the membership functions? Okay, so this is where I think most people get confused. To determine the membership functions of each of the variables, this is what you have to do. So I'm going to take you there and show it to you. This is what you have to do. So what you have to do is that, one, you have to grab the responses that you got from your data collection. So when you grab your responses, you need to know. So here, remember the data set that we are using from the SPSS, they are 66, right? Yeah, they are 66. Oh no, not this. Yeah, they are 66. All right, I just want to show it to you. That's why I'm just. They are 66, right? Okay, so 66 responses. Out of the 66 responses, the question is, how many respondents responded on one? So this is where it's a little bit of work, and you need to put this thing down anytime you are doing this. Please don't come up, don't make it up. Okay, don't make it up. Go back. So here we will see whether indeed you really collected the data or you are just cooking figures. Okay, so from here, as you can see that from what I've done, nobody, no respondent ticked 1 on political extremism. I strongly disagree. But we got 3 people or 3 respondents who ticked 2, which represent disagree on political extremism. And then we got 8 people or 8 respondents who ticked 3, which represent neutral on political extremism. Then we got 36 who ticked agree on political extremism. Then we got 19 who ticked strongly agree. Okay, so this is the response, the likelihood scale. Yeah, so we got all these people to respond. Then the total made up with 66. Okay, so as you can see, I've done that. This is 66. So to get a membership function of the individual variables, what you have to do is that you have to just take a percentage of each of the responses that you received out of the total responses that you got. So if you pick, for example, the political extremism, 0 out of 66 is 0. That's why you see 0 here. But in the second case, it's 3 over 66, and that will give you 0.05. Next, 8 over 66, 36 over 66, 19 over 66. So I hope you got it. And you do the same thing for all the other ones. And that will give you the membership functions of the variables. Very simple. It's not difficult. Okay, now the question is, how do we determine the membership functions of the group? We are talking about the group. To determine the membership functions of the group, which represent the second level, what you have to do is that you have to multiply the membership function of each of the group, which will come in a form of a matrix. So let me put a matrix down for you so that let me show you the matrix. I think some of you have done matrices before. Let me show you just an example of a matrix. Let me show you an example of a matrix function. You did a bit of mathematics, so you know this. Yeah, so it comes in the form of this. The other one was better, but I don't know whether. Yeah, it comes in the form of this. Okay, so this is how matrices come. And with respect to matrix, the rows and the columns multiply and add up to get whatever answer that you want to get. So I want to use this Excel to show it to you so that you understand it. So for example, with respect to getting the membership function of the first, that's on the strongly agree, for the group, what you have to do is that you have to pick the membership function of the first variable and then multiply it with the weight that we assign to them in the other step, 0.109. I've put them here. Put the weight here. Okay, so you pick this times this times this, then plus the next thing in the group, which is old age and disability challenges. This times the weight, this times the weight, this times until you get all of them, and then you sum them together. So this is what I have done. So to make it simple. So, okay. Let me try to do it. So this is what I meant. So as you can see from the screen, you pick, oh, I even added, and there's a mistake. Okay, so that means the first one is wrong, right? Yeah, okay. So the first one, there's nothing there, so it's supposed to be this one, then times this. It's supposed to be like this. So I made a mistake. Okay, so yeah. So as you can see, yeah. So as you can see, all the group members. So the first column times the weight will give you the answer for the first row, the first column. Then the second column times the row, which is the weight, will give you, so this one too, you can see, this is the second column. Oh, this one too, there's a mistake there. Wow, how come? So I have to so plus, like there's nothing there here, so I made a mistake by adding something which is not available. Okay, so this will give us this. This one, I guess there is, yeah, this one is a mistake. So the first one, I can decide to, any of them is acceptable. I can decide to bring the first one first. This plus this times this. Then the next one to, I think this is a mistake. No, that's not where the mistake is. It's rather the other way around. Okay. This times this. Then here too, I think there will be a mistake as well. Yes. So it's this times this. Okay, then let me check these ones whether they are okay. Okay, these ones are fine. So you pick a column, then you multiply it by a row. In this context, the weight are the row, but I decided to make them to look like a column. Any of them, I don't know, it depends on how you want to. Or you can multiply a column against column, or a row against row. Yeah, so that's matrix. Yeah, you can read more about that. Okay, so we have these things done. So that means we have a membership function for the group as well. And the group membership function came out of the membership function of the factors. The membership functions of the factors represent the third level, and the membership function of the group represent the second level. The first level is going to be the overall. So you get the idea. In other words, it's like you are building something, and as contractors or as project managers, when you are building a house, you build from the ground mostly. or most of the times. There are a few situations where you can build a house from the top, but in most cases, houses are built from the scratch. Okay, so we have this. Wow, that's fantastic. Any question? If you have a question, get back to me. Great. Now we have to determine the first or the overall. So how do we determine the first or the overall? So once again, we bring in the membership function of the group. Okay, so the same thing that we determined here. Okay, I decided to put them in a form of a row, but these things can also be turned into a column as well. Okay, so to determine that, you multiply the membership function of the group, which is the second level, in order to get a first level, by the group weights. Remember, for us to get the membership function of the group, we multiply the membership function of the each variable by their weights. So if we also want to get membership function of the first level, then we have to also multiply the membership function of the group by their weight. Very simple. So weight. So this multiply by this plus this multiplied by that. So that's exactly what I've done. And when you do that, you get this first level. So this is going to be the first level. And with this first level, we can now assign the linguistic values to them, or linguistic terms for them. With the linguistic terms are here: 1, according to our likelihood scale, 1, 2, 3, 4, 5. So once we do that, all that we have to do is that we have to multiply this. Okay, let me take this one out. This by this plus this by that plus this by this plus this by this. We just want to determine the critical level or the critical value overall, because now we have read the first level, so now we need to know the overall. So that's what I'm doing. And then this by that. So that means we are getting 3.97, which is approximately around 3.97. Yeah, we are getting 3.97, which is very high. If you have a likelihood scale of, or if you have determined a spectrum, a continuum of 1 to 5, and you are getting an overall value of 3.97, that is big. That's serious. That means these issues are very important issues that need to be addressed. Now let me get back to, so I've done all this, but I just want to go through what Dr. Wuni did, so as you can see, the weightings of the individuals, then the membership functions of the individual variables. And from there, when we multiply them with the weights and adding them to the matrix, we got the level 2, which is the membership function of the group. So they're exactly the same thing that we have also done. Okay, so these things have been explained further here. Okay, I've already explained this, how we came about the membership function of each of the groups, which is determined by how people responded to the variables in the survey. Okay, so we have determined this, we have determined that. Okay, and this thing too has also been determined. Yeah, where you want to look at the membership function in terms of trying to look at the value of each of them, of the values. So you take the weightings times, we have done this. It's almost the same thing as we have done. And that will give you the group. Like here, he's looking at it from the group perspective. So that's exactly what he has put in the table, or this table. So we have done all these things already. Yeah, I don't want us to be repeating ourselves. It's the same. It's just a further explanation, just giving an over. Then the overall. So the overall risk level is what we have also determined, which I showed to you, where you end up determining the first level, and this is where this is the first level. Okay, the first level. Then you multiply it by the grade alternatives, which in this case the linguistic values that you assign to the grades, which you have to determine, because even though it's 1 to 5 according to the Likert scale, it's possible somebody may set something else and say maybe 1 to 7 or 1 to 9. Okay, so once you are done and you multiply them and you add them to give you the overall figure. So here, when he did that, he got 3.30. Okay, 3.30. Okay. So yeah, there's also another way, and that's also what he has also done. Another way by which he did this was that instead of just going straight to the point, like what I have done in the Excel sheet, he started by multiplying the individual groups, their membership functions. So let's go back. If you look at group 1, the membership function of group 1, which is this one, take note of it. Group 1 membership function is this. Okay, this is the group 1 membership function. Instead of doing that, he decided to just multiply the membership functions of the group 1 by the alternative grade set. Okay, by the alternative grade set. Okay, so that is what he decided to do it that way. So he determined it like at the individual level, and that is where he did it from the group level. Yeah, he wanted to find out the group which had which was very critical, and the group which was not critical. So when he did that from the individual perspective, you can see that which of the group is which group recorded the highest. The group that recorded the highest is group 3. Group 3 recorded 3.34. Okay, so this is where you multiply. This is where you multiply the membership function by the grade alternative that you adopted. You want to determine the criticality of each of the groups. Okay, yeah, which I can also do the same. I can do it. It's very simple. Let me show you. So here, if I want to do this, all that I have to do is that I have to multiply 1 by this plus 1 by you. Let me do it so let's take group 1. So if I want to do group 1, all that I have to do is just pick this by 1, which is the alternative grade that we have set, plus this by this, plus this by this, plus this by this, plus this by this. Okay, so as you can see, group yeah, I think I've already even done it here, but it's the same anyway. So group 1 is giving us 3.910. Wow. Then let's look at group 2. I think I did it, if I'm not wrong. Yeah. Anyway, so that's group 1. GCSFI. That's how I name my group. So let's look at GCSF2. Group 2. Let's see the level of criticality of group 2. So group 2 to the same approach. Let me see whether it will work here. I'm just trying to work. Oh, fantastic. That's work. Yeah, that's worked. Is that true? Let me check. Let me confirm. D6. D6. No, that's not wrong. That's not correct. Times D4 is, I think it's wrong. The figures are no, that's not correct. I'm sorry. It's not supposed to be like that. If you do that, you'll get a wrong answer. So I have to change all these things to 4. Yeah. Yeah, 4. All the 5 should be 4. All the 5 should be 4. Yeah, because we are dealing with the alternative, not just, yeah. So all these figures are not correct. Yeah, so this should be also be 4. Yeah, so this is, hey, that's too high. How come? So D, really? We are getting more than 4 point something. That's serious. Okay, so let me do it this way. Now let me apply. Now let me apply this by that. Oh, really? Okay. Okay, yeah, that's correct. Yeah. Yeah, that's right. Yeah, so this is group 2. Group 2 happened to record a very high level of risk comparative to group 1. If you're looking at it from the individual point of view. And overall, we get this. So exactly what we got here. 0.972. Yeah. So this is for individual, and that is what Dr. Wuni did. So if you are looking at it from the individual point of view, like if you want to look at it from group per group, this is what you have to do. So you just take the column, the last column in this table 6. Okay. Then you multiply and add with the alternative grade, which in this context we have set it as 1 to 5, 1, 2, 3, 4, 5, which is somehow related to the Likert scale, or you can say something different. But looking at the data set that we use, the 1 to 5 is advisable. So he determined the individual groups. I mean the groups, each group. Yeah. So and then he determined the overall. Any approach that you want to use, you end up getting the same answer. Whether you want to go by this thing that he did, or you want to, any of them is acceptable. So it's not a big deal, because after determining the individuals, what he did was that he decided to multiply the overall weight, the weighting, and this weighting, like 0.39 to 0.39 to 0.31, you can see it in table, I think that would be table 5. Yeah, you can see it in table 5. In table 5, the last column, table 5, the last column, which represents the weightings of the group, because he's trying to determine the overall. Multiply by, in group 6, the membership function of the group. Okay. Yeah, so that is how comes you got that. So we are just trying to determine the overall value. Yeah. So when you compute that and you get this matrix, You add this, you multiply, add and multiply, you get this. And once you get this, all that you have to do is you multiply it just by how he did the individual, just multiply by the alternative grades. It's 1 to 5 as he has done. So this results from the overall multiplied by another matrix, which is 1 to 5, which represents the grade alternatives 1 to 5. And then you get that. Okay. Any of them, or you can also decide to use these ones. Okay. If you are going to use the group, this criticality indexes of the group, what is going to happen is that you have to multiply the criticality indexes of the group by their total weightings. That's the group weightings from table 5, the last column, which is this one. So you multiply this and add it. You multiply in a matrix form. I mean, you multiply 3.31, 2.28, 3.34, and then 3.32 by their weights. You end up also getting the 3.30. Or another alternative is just, you can also multiply the 3.31, 3.28, 3.34, 3.32 by the alternative grade, and you also may end up getting that. So any of them will work. Okay, so what he did was that he wanted to develop an assessment model for this. And with this assessment model, he just came up with this linear addictive risk assessment model. But in most studies I've seen, most studies don't come out with linear addictive models. So here it's up to you. Yeah, that's why when I set this thing up, I mentioned it in my in step 6. I said it's your choice. You can design a linear addictive model for the analysis or not. So it's not something that is compulsory that you're supposed to do, because in most studies I've read, people didn't do, or scholars didn't come up with an addictive model or a model. Once you get to this point where you determine the criticality indexes or the criticality level, that's fine. You can just move on. The last thing that you have to do is you need to discuss the results. Very important. And the discussion of the results here, you are going to discuss the results from the perspective of the exploratory factor analysis that you did, and also the fuzzy synthetic evaluation results. So you have to do the explanation from here. Okay. So once again, I will encourage you to just take a look at this paper, read it, and just get to know how the interpretation was done. So here you report the results that you got on the exploratory factor analysis, and also the results that you got on the fuzzy synthetic evaluation. I'm so happy that at this level, I've been able to take you through what we call fuzzy synthetic evaluation using a simple and straightforward data. And I'm hopeful that once you are done watching this, fuzzy synthetic evaluation modeling will be something easy for you to do. Yes, so I have used a simple data, but don't forget the same idea or the same knowledge that you have acquired here, you can apply it to a data set which is big, and you are going to get almost the same, or I mean you get the same results. It's almost the same. You get the same results. Okay, I wish you all the best, and I'm so happy that we are making positive progress. So I'll come your way either ending of this week or next week with the other 2 videos, which are also on fuzzy synthetic modeling. But this time around, or when I do that video, what I will do is that I will take other papers. Yes. So I wish you all the best. Take care. Please, if you have a question, I'll be so happy, and I'm ready to come your way and assist you. Okay, so I'll be so happy to assist you with whatever question that you have. Thank you so much, and God bless you. Bye.